sine function, okay? And like we said, we're just going to go through the steps like we did yesterday a little bit more efficiently because we already have the general idea. And then that should give you guys good examples to work on the homework with. So the first thing we want to do, like it says up here, is we want to rewrite the function in that format. So specifically that b value separated from the x minus h. So see that we do have this b value here and something added or subtracted to x. So we want to rewrite it. Okay? So we're going to write y equals, we have that a value of -2, but we want to separate the 2 from the x minus h quantity. And so for those of you that struggle a little bit with this, I know it has pi in it, but like that means there's still just going to be a pi in it. So if you want to, you can just think about like the number in front of pi, which is right now a 1. And remember that when you factor something out, you had something and you're basically dividing it by that number to see what's left. So if you really struggle, be like, okay, before it said minus pi, I took out a 2. So I'm basically taking negative pi and I am dividing it by 2, which is like timesing it by a half, which would leave me with negative pi over 2. And then it should make sense. And what I mean by make sense is that if you put the 2 and distribute it back in, you should get what you started with previously. Like, so 2 times x should make that 2x, and 2 times pi over 2 should make pi. And so that looks right the way we have it right now. Okay. And so that gives us an a value of -2. Okay, so 2 things are happening with a, the negative as well as the 2. We have a b value of 2, an h value of pi over 2, and a k value of 1. Is everybody okay with the rewriting and recognizing the different values from the equation? All right, so now we're going to try and set up our points to graph using our transformations, which means you guys have to know your parent. So you guys can see if you know it right now on your own. So this is a sine graph. So personally, I know that the sine looks like this. Okay. That helps me a little bit knowing that it starts at that 0, 0 point as far as when I set up my parent function. So if you like that visual, then that might help you. So remember, from 0 to 2 pi by 90 degrees, which are the pi over 2's. Okay? And so sine starts at 0, it goes up to 1, back to 0, down to -1, back to 0. If you struggle with that part, if you can at least get the x values, remember you have your unit circle, and on the first day that we even talked about this, you guys figured out all the sine values that went with those, so you could figure those out from your unit circle. And then we're going to have to set up our table for our transformations. So let's look at our transformations and what it's going to look like on here. All right, so we have an a value of -2. So is a going to affect x or y? What does it affect? The x coordinate distances, horizontal distances, or y vertical distances? The y value, right? So our y's, and the vertical stuff is very straightforward. It does exactly what we would expect in the equation. So our y values are going to get multiplied by a negative as well as a 2. And that's 2 different things happening. What is multiplying by the negative doing? Every time we multiply by a negative, that is a reflection. Because y is changing, that means the points are flipping over the x-axis. Okay? What does multiplying the y by 2, what's that going to do to our function? Stretch it. Good. Timesing by numbers either stretches or compresses. And we're not looking at the negative because that's a reflection. So timesing by 2 makes distances bigger. So it's a stretch. And because y is a vertical measurement, that's a vertical stretch. All right. Okay. Then we have a b value of 2. Okay. That comes from in here. Is that value going to be addressing our horizontal or vertical distances? Horizontal, okay? It's something that's applying to x. And that horizontal stuff we saw isn't what we'd expect by first glance at the equation. We've looked at it enough that we want to change our expectation, okay? So hopefully we have. That value being a 2 in the equation really means our x distances are getting multiplied by what? 1/2, okay? And if we're multiplying the x distances by 1/2, then what's happening is those horizontal distances, so it's going to have the word horizontal, are being compressed. So we have a horizontal compression, okay? Smaller horizontal distances than we had before. And then h is pi over 2, so we're going to add pi over 2. And that's going to be a shift right pi over 2. I know it's a weird number, but it's not really a weird number in the context of what we're doing, right? Our x-axis is labeled with angles, so it's not that weird for us. That's an angle that we'll be shifting over. And then lastly, our k value is 1, so that's going to add 1 to our y coordinates, and it's going to shift our graph up 1. Okay. Is everybody okay with like the headers on our chart here, like where these numbers came from, why we're doing what we're doing, and then verbally how we explain what's happening to the graph? All right, so then we have to actually do the arithmetic. So again, y column's going to be okay, but x column's going to be a little bit more difficult. So let's just go ahead and fill in the y column first, since you guys are probably a little more comfortable with that. Okay, that's for our y values. And then look at what we're doing for each x value. Okay, so each x value has to get multiplied by a half, and then we have to add pi over 2. So we have to do fraction multiplication and then fraction addition. Okay, so 0 is not bad because 0 times a half is 0, plus pi over 2 will just be pi over 2 still. All right, then we have pi over 2. So I'm going to do a half times pi over 2. That's going to give me pi over 4. Yesterday, that's all we had to do. Ours just had a horizontal stretch or compression, but this one has a shift in addition to that where we have to add pi over 2 to that. Okay. And so then remember when you're adding fractions to make common denominators. So 4 would be a good denominator, so I want to make this times by 2 and this times by 2. So I basically would have pi over 4 plus 2 pi over 4. So that makes a denominator of 4. And pi plus 2 pi makes 3 pi over 4. Okay, so patience either with yourself or with me if you curse me every time you have to do this, okay? So like just take your time a little bit. You guys are all capable of doing this. It's just about whether or not you let yourself actually do it, okay? All right, so next one up, pi. So I'm going to take pi and multiply it by a half. That's going to give me pi over 2. I'm then going to add that with pi over 2. That's kind of nice because they already have a common denominator. So 1 pi over 2 plus 1 pi over 2 makes 2 pi over 2. Okay. But that reduces to just be pi. I know it's kind of weird that pi still turned into pi, but that's what happened with those operations. It happens sometimes, okay? All right, then we have 3 pi over 2. We're going to times that by a half. So that's going to give us 3 pi over 4. And then we have to add pi over 2 to it. And again, here you'll have to make a common denominator, which again would be 4. So this will be like 3 pi over 4 plus 2 pi over 4, which ends up making 5 pi over 4. And then lastly, we have 2 pi. So a half times 2 pi. The 2's will cancel out and just make pi. And we have to add that with pi over 2. Again, you'll need a common denominator. So we'll have 2 pi over 2 plus 1 pi over 2 will equal 3 pi over 2. Is everybody comfortable with where our chart is coming from? Okay, so you just have to wade through those a little bit. All right, now before we go put our stuff onto the graph, we're going to want to scale our graph appropriately. Counting by ones will still be fine for the y-axis. We'll just make sure it reaches all the way up to 3 and all the way down to -1 because those are the highest and lowest values that we see. Okay. How are we going to figure out how to scale our x-axis? So this does not have a 0 in it like yesterday. You can't see starting at 0, the next mark should be this. I don't really know if that should be the next mark or not. Olivia? Good. To figure out our scale, we're looking for a pattern in the values here. We want to see how far apart they are. So we're going to pick 2 of the values and subtract them. Okay? Maybe I pick these 2. I don't know. It doesn't matter. We should get the same answer no matter what. Okay? So I'm going to take, for my scale, I'm going to take pi and subtract 3 pi over 4 and figure out how far apart those are. Some of you don't really have to do the subtraction, but some of us do. Okay, I would need a common denominator to do the subtraction. So that would be like 4 pi over 4 minus 3 pi over 4, which gives me 1 pi over 4. So I'm going to scale my graph by pi over 4s. That means every time I make a tick mark, I'm going to count it as a pi over 4. And then hopefully I should see these numbers show up in there where I can graph points along there. It should make my life easier. Okay, so let's go ahead and try that. So on my x-axis, okay, I'm going to start with 0, and I'm going to make that first mark pi over 4. And then I'm just going to start counting by pi over 4s. So that's 1 pi over 4. The next one would be 2 pi over 4, but that reduces. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. Okay, get the idea. And then you can do the same thing in the negative area. If all your points are positive, I'm fine with you doing what I'm doing right here and just saving that like that. I can see how they're labeled. If you have some that are negative, you want to probably at least start labeling the negatives just for yourself so that you plot them in the right spot. Okay. And then we were going to count our y-axis by 1s. We were going to make sure that we reached from -1 up to +3. So I'm just going to make sure that I have places for all of those points. And now hopefully I can go back to that table and easily plot the points that I figured out for my graph and that they look like a sine wave. So we'll see if that happens. So when we go back, it had pi over 2, 1, 3 pi over 4, -1, pi 1, 5 pi over 4, 3, and then 3 pi over 2, 1. Okay, before I fill anything in, I want to make sure that this makes sense. Okay, so think about filling it in for a minute. If I just went from left to right, but I know it's a curve, it's going to be a curve that starts here, goes down, goes up, comes back. So remember the picture we had in our head of a sine function graph. Okay, does this look like a sine function graph? So like, did our sequence start with these points all along the midline and then it hits a max and a min somewhere in between there as well? Whereas the cosine graph had like the max values more like a U when we made our first one. So this makes sense, right? This is the middle of my function. That's the highest point and that's the lowest point. Is that okay with everybody? Now I could continue and fill in some more points so that I can see not just this one section of the graph, but sections on either side of it. So again, remember this is the middle. And so here our pattern goes from the middle to the low point, back to the middle, to the high point, back to the middle. So the next point I graph should be the lower point again, okay? Then it should go back to the middle, and then back to the high point, and then back to the middle. I could extend it the other way as well if I wanted, okay? So here we were at the middle, but before that was the low, so here I would want to go to the high point, and then back to the middle, to the lower point, and back to the middle, to the higher point, back to the middle, okay? You could keep going forever and ever and ever. And then that should make you nice sine waves. Okay. And then we have to be able to state some of the characteristics of the graph, okay? So what did we say that you should start with for the period all the time? Sine and cosine graphs, they have a period of 2 pi for their parent function. So you should start by writing that down all the time, because if there's been no change, then that's going to be your answer, okay? So I'm going to write down 2 pi. Then I have to ask myself, did I change the wavelength or the period? What's the only kind of transformation that changes the wavelength or the period? So, not a reflection. To change the length of the wave. What's that? The B value, yeah, stretching or compressing, right? So did we do that? We did. And look at how you measured things on the graph right here. Okay, you took the x values, you took the horizontal distances, and they were adjusted by being multiplied by 1/2. Then the same thing is happening to your period. If all the distances have been multiplied by 1/2, the same thing's happening to how long the wave is. So it used to be 2 pi, you're going to multiply it by 1/2. Those 2's will cancel out, and the period of this graph should be pi. Okay, if you have the graph in front of you, you can check and see if it makes sense. Does it look like in ours that if I go from 0 to pi, that after that it's the same pattern starting over again? So here's 0 to pi. Does that look like one complete sine wave? And then does it start the pattern over again? Okay. All right, frequency is just the reciprocal of the period. So if the period's pi, the frequency is 1 over pi. And then amplitude. What do the parent functions have as their amplitude? Because that's what you're going to start with every time. 1. And then you have to ask yourself, did you change that? So amplitude is not changing the center of the graph, but stretching the minimums and maximums of the graph, or compressing them closer to the center or further from the center. So again, you want to look right here. Okay. We took the vertical distances and we times them by -2. We don't want amplitude to be negative. It's a distance measurement. We always want it to be positive. So the negative part doesn't matter to us because that's the reflection. Okay. The 2 matters to us because it made these distances 2 times longer than they were before. So if the peaks used to be 1 unit from the center, they were just stretched 2 times more than that away from it. So 1 times 2 ends up equaling 2 for our amplitude. Okay. And then our phase shift is if we shifted our graph to the left or to the right. So you should be looking specifically for a horizontal shift. You already wrote it down in the transformations. We said we shifted right pi over 2. That's now just something that's called phase shift. So our phase shift is to go to the right pi over 2. Okay. All right, any questions?